So now that we've come to the end of our unit, we're going to take a second to look at everything we've covered so far that's going to be on our upcoming test. So to begin with, we started with arithmetic sequences. And remember, you know that a sequence is arithmetic if you are adding and subtracting the same thing every time. And whatever we add or subtract is called our common difference, which we label with a D. We have two forms that we look at. One is our explicit, which is the one we use most often. And our explicit formula is a sub n, which is talking about whatever term we're looking at right now, equals a sub 1, your first term, plus parentheses n minus 1 times your common difference. And a sub 1 is your first term. We use this for multiple reasons. One, if we can write our equation, then we'll plug in whatever term we're looking for, and it'll tell us what term that is. Or if we're looking for the first term or looking for what term it is or the common difference, we can plug in everything and just solve for whatever we're looking for. The recursive formula is not as common, but it's the a sub n, so the term we're looking for now is the term before, plus the common difference d. And then we always say that a sub 1 is whatever, so we say where it starts at. So the term we're looking for, the next term, I guess, is the now term plus the common difference. Geometric sequences, we know they're geometric if we multiply and technically divide every time, but really we multiply. And whatever we multiply by is our ratio, which we call r. Okay, so remember, if I'm multiplying by 2 every time, that's a little easier, and if I'm dividing by 2, it's really multiplying by 1/2. Okay, and just like our arithmetic sequences, we have two equations. The explicit is a sub n equals a sub 1 times r to the n minus 1. And a sub 1 is your first term, r is your common difference, and then to the n minus 1. Our recursive formula is the next term, a sub n, equals the now term, a sub n minus 1, times whatever your ratio is. And we again say a sub 1 equals whatever your starting value is. So those are our geometric and arithmetic sequences. Now remember, your geometric ends up creating an exponential curve because we have a variable in our exponent, and our arithmetic ends up being linear. Okay, so we have linear and exponential. Then we moved into regression. We did linear, quadratic, and exponential regression. But now we're trying to determine which one is the best fit for that particular data. So this is a lot of calculator stuff that we have to remember. So like entering in our data, we go to stat edit. And then if we want to find our line of best fit or curve of best fit, we go to stat calc. But remember, you need to make sure that your diagnostic is on. And you do that by going to second 0 and going down diagnostic on. And then if you're ever going to look at your graph, which you may not always, but if you do, you want to make sure you turn your stat plot on. And to do that, you go to second y equals. The important one is definitely your diagnostic. Okay, because turning that on is going to allow us to see the correlation coefficient r. And remember, r can be between -1 and 1, and the closer it is to -1 or 1, the stronger the correlation. So that's our correlation coefficient. So sometimes you may need to go through and find all 3 regression models, and then just look at your r value to see which one is the best fit. And whichever one is closest to either -1 or 1 is the best fit. And then the last thing we looked at was systems of nonlinear equations. So we looked at linear, quadratic, and exponential, and we have 3 ways of solving. One's elimination, but remember we only use that for 2 linear equations, so a linear system. And then you have substitution and graphing, which always work. So make sure you're able to solve a system either of those 3 ways. And that's everything we've looked at this far in our units.